This video is going to be a really quick, brief introduction to a key concept called enthalpy of fusion, or latent heat of fusion. So it's the delta sign, FUS for fusion, the H for enthalpy, and the little circle means that it's a standard value. So it's the same value regardless. You always are going to use the same value. So what is it? Well, when we have a heating graph like this one here, we've heated a solid and its temperature is increasing because so T is for temperature, there is an increase in kinetic energy as the particles spread out. But then you get to its melting point and there's no increase in temperature at all for a while. We're still pumping energy in, but what's happening instead is melting, hence melting point. All that energy, because energy has to be conserved, is going into breaking bonds. And we should recall that bond breaking is an endothermic process. Once all of it has melted, we then expand again. So we're exploring this section here where melting is occurring. The enthalpy of fusion, or latent heat of fusion, is the amount of energy absorbed by 1 mole of the pure substance for it to melt. So there are some key points. It's the pure substance, it's 1 mole, and it has to be at its melting point already. So if we took it just before or just after, we would be getting incorrect values. So at the melting point, the amount of energy required to turn 1 mole of that substance into a liquid. If it was water, I could represent it this way. So I've got H2O solid turning into H2O liquid. I've got a positive value for the enthalpy of fusion. I think it's 6.0 kilojoules per mole, but I know it's going to be positive. They'd give that to you in a question, so you'd record that equals positive, whatever it is, kilojoules per mole. And I've got my temperature, 0 degrees Celsius, because that is the melting point of my substance.